You are welcome back. I promise that we are going to consider other formulas that involve radicals. And when I say radicals, I have explained that radicals, they contain two or more atoms, okay, and they carry they carry valency or a particular charge. Okay, without wasting time, all this formula contains radicals. These are not all the radicals that we have, but you just need to understand the concept. Once you've understood the concept, it will be very easier when you see any radical, how you can easily combine the formula together and then you get a correct formula. Now let's start. Potassium. You know the potassium already now. We are talking about potassium triisocarbonate 4. So this potassium is a single ion on its own. Potassium ion. If you want to talk about potassium ion now, we'll be talking about K. K is the symbol for potassium. And what is the valency of potassium? The valency of potassium is 1. Okay? Now, triisocarbonate 4. Let's start from that word, tri. Tri means what? 3. 3. Also means oxygen. Also. And then carbonate, C. I know somebody is asking me, uncle, you write 3OC. And then you still put another 4 here. Yes. This 4 is what we call oxidation number. It's still part of what we are going to consider in this class. How do we arrive at this 4? This 4 is called oxidation number. But that is not what we want to do right now. So, triisocarbonate 4. This is an ion. If you want to express this in form of ion, the valency of this CO3 is 2. Go back to the previous video. I have discussed this radical. So this radical CO3, the valency of this CO3 is 2, and it is 2 minus. And remember, I told you that anytime you are combining from ions together, you must write the positive ion first before the negative. So right now, these 2 will come here, and then this potassium triisocarbonate 4, the formula we are going to have eventually will now be K2CO3. You can replace potassium with sodium. If it is sodium triisocarbonate 4, it will still give you this similar formula. The only thing that will be different is the symbol of sodium will be here instead of the symbol of potassium. Now let's consider that of calcium hydroxide. You know the symbol of calcium, that calcium is Ce. And what is the valency of calcium? What is the valency? The valency of calcium is 2. Are we together, please? Then this hydroxide is also a radical, and it is OH. It is OH. So that's that hydroxide is called OH. That's the radical. And then what's the valency of that OH? The valency of that OH is 1. Is 1. All these radicals, this how to master them. Check the radical, read your note, go back to the textbook. Like I said, I recommend New School Chemistry, written by Ababio, and then Understanding Chemistry, written by Godwin Ojukuku. Those 2 textbooks, I recommend it. You can be very sure, I'm very sure of it, that you gain more value from there. Okay, so try as much as possible to go through those radicals and then master their valency. Then you are good to go. So OH here, the valency is 1, which means that the way we have been doing it, 1 will move to this place, and these 2 will come here. But let me say this again. I have said it repeatedly, that anytime a number will be added to a radical, a valency will be added to a radical, or a radical is taking another subscript number. Peradventure, maybe that radical has a base number before, like this one, and then you want to put another number at the base of that radical, that radical must be enclosed in brackets. This is it. It is wrong for you to write this formula like this. CaOH2. Look at this. You know you can write the formula like this, and you can also write the formula like this. Ca, open bracket, OH2. It is wrong for you to write like this, whereas this is correct. You know why? This radical must be in bracket before these two come to the base. Do you know why? These two affect both oxygen and hydrogen. But if you just put 2 here, these two will only affect hydrogen, it will not affect oxygen. And we say radical behave like a single unit. Do you get it now? The same way, this one, which is the valency of OH, is for both oxygen and hydrogen. Do you get it now? So this is the formula for calcium hydroxide. And then magnesium triazonitrate 5. Magnesium, what's the valency of magnesium? Magnesium is T2. The valency of magnesium is 2. And then triazonitrate 5. Like I said here, tri means 3. Also there is oxygen. Nitrate there is nitrogen. The next thing is, what is the valency? So the valency of this one is 1. The valency of NO3 is 1. The same rule that we applied here is what we are going to apply here too. You know, this one already has a base number. If you write like this, you know, you can write like this, Mg, NO3, and you put 2 here. Or you can write Mg, NO3, you know, you put everything in bracket up and put 2 at the base here. This is another way of writing it. So in this case, this one is totally wrong and this is correct. You know why? There is a base number here. Even if there is no base number here, as long as the radical is taking a number greater than 1, that radical must be in a bracket. That radical must be in a bracket before the subscript number come and meet it. Please, if you don't understand it, make sure you listen to this video over and over again. You will get it. Trust me, chemistry is not hard. You can understand this. And these are the basic things you must know. You need to learn this because you are going to make use of it. And you will pass. You will write that exam and you are going to pass it. So, anytime you are going to put number at the base of a radical, that radical must be in a bracket before you put the number there. I think I've been able to explain that very well. Let's consider the ammonium tetraoxobases. Ammonium is also a radical, and then the formula is NH4, and the valency is 1. Are you with me? Then tetraoxobase again. Tetraoxobase, tetra means 4, also means oxygen and sulfur. So the valency of SO4 is what? Is 2. The valency is 2. So in that case, we still go by the rule. So we are going to have NH4 in brackets, subscript 2, then SO4. You know these two will come here as a base now, and then we must enclose it in brackets. So lastly, before we end this class, we have aluminium tetraoxobase. You should be able to do that too. Aluminium is Al, the valency is 3, and then tetraoxobase is also SO4, and the valency is 2. In this case now, you know they have 2 different valency now, so they are going to interchange it respectively. So 2 will come here, which is Al2, open bracket, SO4, close the bracket, 3. They are just going to interchange it since their valency are not the same. I hope you understand this. In the next class, we are going to be making use of this formula to calculate molar masses. to calculate molar mass. Thank you for watching. Bye.